Hi everyone, we're going to look at how to do factoring of trinomials where a equals 1. What that means is of the form ax squared plus bx plus c, the leading coefficient of a is always going to be 1 for these examples that we're going to see in this video. So you'll see here x squared in all of them, which is really just 1x squared. That's why it's of this type. Okay, so the way we do this is we have to look at what multiplies to our c number and adds to our b. So the 12 is going to be c, and b is 7, again from this form right here. So you want to remember multiplies to c, adds to b. So we want to multiply to the 12, and we want to add to the 7. So I need two numbers that multiply to 12 and add to 7. If you need help, you can always just write down all the factors of 12. So 1 and 12, 2 and 6, 3 and 4, and that's it. So which two of those add to 7? Well, this is 13, this is 8, so those aren't going to work. This will, 3 and 4. So that's what we need, 3 and 4. So when we go to factor this, it's going to look like this. Two sets of parentheses, x's in both in order to get x squared. And we want to use that 3 and 4 like this. It's going to be a plus for both since we're multiplying to a positive 12, adding to a positive 7. What we've essentially done is done our multiplying backwards. That's what factoring basically is. It's undoing the multiplication. So you're thinking about how can I take all these three pieces and get it into some kind of rectangle where it's something times something, length times width, produce those three area pieces. So an x squared area would be x times x, and then the 12 usually we put in this box just for fun. So you're trying to find ways to get, so these two numbers here are going to multiply to 12, but then these two areas got to add to 7x, and that's where it gets a little tricky. So the 3 and the 4 multiplied to 12, and then if this is x over here, this is x over here, this would be 3x. This would be x up top, this would be 3, this would be 4. So if this would be 4x here, and it's a positive and a positive. So there we have it. So our area pieces here added up to 7x, and everything else was also correct. We had the x squared and the 12, so our length and width are x plus 3 times x plus 4. Negatives make it a little bit more tricky. We're going to multiply to the negative 18. We're going to add to 7. So if we're adding to a positive but multiplying to a negative, well, the multiplying to a negative part is the key part to focus on, because in order to get a negative product, you need one negative, because two negatives make a positive when you multiply them. So if we get a negative product, one has to be negative. So that's good to keep in mind there. So we're going to need two numbers, one of them positive, one of them negative, that multiply to negative 18 but then add to 7. So a little bit tricky. We can again go through the list. So 18 would be 1 and 18, 2 and 9, 3 and 6, and that's it. So which of those are 7 apart now? Not a total of 7 like it was before, 7 apart, because one's going to be negative, one's going to be positive. And that's going to be 2 and 9, because those are 7 apart from each other. So we're going to use 2 and 9. So we'll do the same template. So x and x make x squared, 2 and 9. But we want to add to a positive 7, and one of these two has to be negative. So we got to think about that. Well, if I did this negative and this positive, they would multiply to a negative 18, but a negative 9 times x over here would be a negative 9x plus 2x, and that's a negative 7x, not a positive. So that would not be right. So we got to undo all of that because our symbols are backwards. So in order to add to a positive 7, the bigger number has to be positive and the smaller has to be negative. That way, if you were to remultiply this out, we would get the original. X times x is x squared, x times 9 is 9x, negative 2 times x is minus 2x, negative 2 times 9 is minus 18, and there's the original, x squared plus 7x minus 18. If you switch to signs, it just wouldn't work. You'd have a negative 7x instead, because that would be negative and that would be positive. So that's how we do it when there's one negative, or when we have a product that's negative and we add to a positive. Over here we've got a positive product and a negative sum, which is kind of weird, right? How can you multiply to a positive number but have a negative sum? Well, they got to both be negative. This has got to be two negative answers. So, or negative numbers here. So we got to think of numbers that multiply to 60, but then would add to 16. So 1 and 60, probably not going to work. 2 and 30, nope. 3 and 20, nope. 4 and 15, nope. Are we ever going to get there? Hopefully. 5 and 12, nope. How about 6 and 10? Yeah, that sounds pretty good, because 6 plus 10 is 16. So we're going to use 6 and 10 as our two numbers. So it'll be x and 6, x and 10. But if I did a plus here, we would have x squared plus 16x plus 60, which is just a little bit wrong because you got to have a negative 16x. We can't do a plus there. We've got to instead do minuses for both of them. That way when you remultiply it back in, it'd be x squared minus 6x minus 10x plus 60, which is x squared minus 16x plus 60, which is what we had to begin with. So we're good. That's how we factor our trinomials when a equals 1.